You all are welcome to MakeBot tutorial once again. You are welcome to our topic, mapping and functions. Do not forget our hashtag. You don't need to be a scholar to get an A. Okay, mapping and functions part 1. Now, what are mapping and functions, or generally what is mapping? Now, I'm going to be using this illustration to explain the meaning of mapping. Now, consider the diagram below. In the set A, we have 1, 2, 3, and 4. This is the set A. And in the set B, we have A, B, C, and D. This is the set B. Now, from the diagram, we can see the following comments. The first comment here is that set A is called the domain, while set B is called the codomain of the mapping. So set A is the domain, and set B is the codomain. Why is set A the domain? As generally, the set at the left-hand side is always called the domain, and the set at the right-hand side is called the codomain. But what are the other reasons? Let's look at this comment number 2. Each element of the set A has a unique image in the set B of which it is mapped into. So for a set A to be called the domain, it must have unique elements to which it is mapped to. Like example, the element in set A has an image to be seen. The element 2 in set A has an image to be D. The element 3 has an image to be B, and 4 A. So the elements in the codomain or in the set B are representations of elements in the domain. So we can generally call this a what? A mapping. Is that okay? Now, the functions that assigns each element in the domain to the codomain is called the function. What do I mean by that? Okay, let's use our pen to write that. In this case now, my function, which is f of x, my function f of x could be 2x minus 3. Do we get? So that formula or that equation or that function in general that assign elements in the domain, or rather that assigns elements from the codomain to the domain, is called our function. Why this representation itself is called the mapping. I'm sure we understand this simple explanation on mapping and functions. Now let's read the rest. It says, therefore, a subset of the codomain B represents all elements in the domain A. This is A. Okay. Hence, you can say f of 3 equals B, which means B is the image of the element 3, or f is the image of 3, or the image of 3 is B. Sorry. Now, so we can say f, that's a function of 2, f of 2. The image of f of 2 is D. Do we see that? So a question can come, what is the image of element 4? So we write it in this form, f of 4 is equals to A. Do we get? Okay, I'm sure we understand that. Now, let's look at something very important, which is called range. Now, we have looked at 3 things in mapping, and actually 4 things. The first one is the domain. Domain is just like the mother element, while codomain is a set of the images to which the elements in the domain are mapped to. Do we get that? While image are the representations of the elements in the domain. Now, range itself is the collection of all the mapped images of the elements in the domain, which also means the collection of the mapped images of the codomain. Example, let's look at this diagram. We can see that this is the domain, while this is the codomain. Now, each element in the domain has been mapped to an element in the codomain. So this first one can be called the image of element B. This second one can be called the image of elements A and C. And the third one can be called the image of element D. Together, they can be referred to as the range of the domain, of the elements in the domain. Do we understand? So the range is the collection of the representators of the elements in the code in the domain. So we can we can actually say the range is synonymous to the codomain. So that's just very how it is, very simple. So in this case, in this second case, this A is our domain, while B is our codomain. Elements 1, 2, and 3 have been mapped to 5, 6, and 8. So in this case, 7 is not an image. So 5, 6, and 8 are the range in this mapping. Do we understand? So I believe we do. Now let's look at key factors to be considered if a relation is a mapping or a function. So a relation can either be a mapping, or it can be a function, or it can be both. Let's look at some of these key factors. The first factor, actually, we are going to be looking at some examples which should give us a clearer picture of all these talk. Every element in the domain has an image in the codomain. Every element in the domain must have an image in the codomain for it to be called a mapping. Is that okay? Look at all these examples. You will notice that in the examples, all the elements in the domain have an image in the codomain. Once that is not the case, in this case, like look at this C, in this case, B is not being mapped to anything. Because of that, this is not a function, this is not a mapping. Do we understand? Yes. Now the second says the images in the codomain has at least one element N in the domain. At least the images in the codomain must have at least one element in the domain. So let's solve. Okay, before that, let's look at the types of mapping. Now we have many types of mapping. We have one-to-one mapping, we have onto mapping, we have composite mapping, and so on and so forth. Let's look at one-to-one mapping. Now consider the mapping of A is a function of B. Now let this be the mapping of set A into B. If it's a mapping of set A into B, it is telling us that set A is the domain, while set B is the codomain, right? Now this forms the correspondence between them. Now that mapping is a one-to-one mapping if different elements in the domain A have different images in the codomain B, then the mapping F is said to be what? To be called a one-to-one mapping. Example, this first one is called a what? It's called a one-to-one mapping because each element has a unique image or has a unique representation in the codomain. So 2 is not mapped to two elements in the codomain. So each is mapped to a single element in the codomain, such as this one. Each has been mapped to a single, so each has an image represented in the codomain. So because of that, this can be referred to as a what? As a one-to-one mapping. Okay, let's look at this. This is also a one-to-one mapping because 16 is merged to 4, 4 is merged to 2, and 9 is merged to 3. So this is an example of a one-to-one mapping. Why this is not an example of a one-to-one mapping? Why? Because 2 elements in the domain are being mapped to 1 element in the codomain. So they both have these 2 elements, minus 2 and 2 have one image or are sharing one image in the codomain. So it is not unique. This image no longer becomes unique, and because of that, this is not a one-to-one mapping. Okay, let's look at the second type of mapping. Okay, before that, let's look at some examples. This example states let P be the set of real numbers, and let F be the function between P and Q. And let this be a mapping such that fx equals 2x minus 1. So the function connecting set P and set Q is what? Is 2x minus 1. Now the question is this mapping one-to-one? How do we know that? The first thing to do is to understand that your x, or rather your P, is a set of real numbers. Is that okay? Now we are referring to set of real numbers, which can be 1, 2, 3, and so on and so forth. So in these examples, we are using let x equals 2, 3, and 5. We are using numbers 2, 3, and 5. So using our fx equals 2x minus 1, let's say f of x equals 2 into what? X minus 1, right? Now, in this case, let's assume our x equals 2. So that's why we have f of 2 here. So we have 2 into 2 minus 1. 2 times 2 is what? Is 4. 4 minus 1 is equals to 3. Now, same thing here. F of 3, it will be 2 into 3. That's 2 times 3 is 6. 6 minus 1, 5. F into 5, 2 into 5, that's 2 times 5 is what? Is 10. 10 minus 1 is what? Is 9. So we can now, once you've done this calculation, you should be able to draw your mapping. So 2, 3, and 5 becomes our domain, right? Because it is used to get these images. While 3, 5, 9 are the images of our domain, which we put in the codomain, and which we can also refer to as the range. Okay, we can see that the value of 2 is 3. So 2 is mapped to 3, and the value of 3 is 5. So 3 is mapped to 5, and 5 is mapped to 1. So we can refer this as a one-to-one mapping because each element in the domain has a unique element in the codomain. Do we understand that? Okay. Now let's look at the second example. Now this is beautiful. Ordinarily, looking at this, would you say this is a one-to-one mapping? Of course, no, because this element B is being mapped to 2 elements in the codomain. So because it is mapped to 2 elements, 1 and 3 in the codomain, this is not a one-to-one mapping. And as we remember, it is not a one-to-one mapping because one-to-one mapping, each element are mapped to a unique element in the codomain. Okay. Now this brings us to the end of this class, mapping and function part 1, where we talked about I introduced to you the meaning of mapping and functions, and I explained some key elements like the domain, the codomain, key factors for a mapping and function to be considered a mapping and function, and we talked about the one-to-one type of mapping. In our next class, we are going to be looking at the remaining types of mapping, and we are going to be solving examples on this. Thank you for watching. Thank you for listening. Subscribe to this channel at Midbox Tutorial for more videos. Thank you.